it's finally time to check the source code of my Azure Functions. So let's do that. As you can see here, I'm in a Visual Studio Code and I prepare basically a few functions just to use them as an examples of what you can do and what you need to be aware of where you will create your own functions. So my first function here called health, what is important to realize is that, as you can see, it looks more or less as a regular web API controller with a few modifications. So first of all, I have my method run, which is marked with function name. And also I'm using the HTTP trigger. And here I have the HTTP request object, which will basically has all the parameters of my HTTP request. The difference between Azure Functions, which uses HTTP triggers, and the regular web APIs is that web API actually gives you a full control on HTTP context, routing, modules, and stuff like that. With the Azure Functions, all the Azure Functions basically work based on event-driven approach. So each and every time an event will occur, the function will be triggered. And those events, they can be different. In my case here, the event is a new HTTP request. The other examples of the events may be, for example, a new message in a queue, or a scheduler, basically a timer, or something like that. So here, as I was saying, in this request object, you actually have all the properties of your HTTP request. But if you will try to access, for example, HTTP context.current, that will be equal to null. So you don't have basically that framework of web API here yet, because the concept is different. But anyway, let's check actually what I also configured here. So first of all, I said that my authorization level is equal to anonymous, and this function will react on a get method. This is a pretty simple and straightforward kind of a health checking function. As you can see, I have nothing actually here. I'm just returning the OK object result with the healthy word to the caller. Of course, if you want to use this one as a health check endpoint, you may want to, I don't know, go and check that you have connection to the database and that connection is valid and database is still there and stuff like that. So probably this function should be renamed from health to keep alive. But anyway, this is the good example that you can use. You can ping this function, and if it will reply with HTTP 200 OK, it means that at least Azure Function Runtime was able to start and was able to run and execute your function. The next function I want to show you called headers. So this is very useful for the, let's say, debugging and the understanding of how you can work with that HTTP request in a context of our business needs. But what I want to show you here is that this is the same more or less signature. I have a function name attribute, I have my HTTP request here, and what I'm doing, I'm basically creating a string builder, and then I'm iterating through the headers in my HTTP request. I order them by key and basically populate a table with those headers. And then I just return it to the user. So as you can see here, another difference is that I don't have here the support of the Razor template engine, for example. If I want to generate an HTML and if I want to return that HTML to the user, so kind of emulate, like a regular ASP.NET MVC application, that's possible, but I still need to do all those hacks with basically either rendering the HTML in my own way or somehow hack the ASP.NET MVC Razor basically templates here. But anyway, the point is that I was able to create an HTML and I return it back as a content result with the content type text HTML. And you will understand in a moment why I actually need to have those functions. Because here's where all the magic actually happens. But the magic is very simple, of course. So the redirect function, this is the function which actually handles all my redirects. Let's check what I have here. So first of all, the flow works as I described. So as soon as I get the request, I will call my getIP-from-request method to basically get the client, the end user IP address from the request. Then I will call it a third-party service, and again, I'm just using it here as an example. In the real life, if you don't want to be dependent on the third-party service, you can basically acquire a database of all the IP addresses with the correlations to which countries they belong to. But again, for the sake of this demo, I basically use the third-party free API for that. So I have my IP address, I call that API, and I basically try to understand what country this IP address belongs to. Then what I'm doing, I'm checking the location parameter, because that API returns kind of a big and complex object to me. I check this location parameter. If the location parameter is present, it means that the IP address was successfully matched to one of the countries, and I will create a redirect result. And that API that I am using, it will actually send me a URL to this particular country flag, basically to an SVG. So the idea here is that if I was able to match the IP address to the country, I will be redirected to an image with this country flag. If I was unable to do that, I will be redirected to my API headers functions. Let's also check those two other methods below. So getIP-from-request. This is really important part, because when you're working in this global setup, because you may have a lot of hops, a lot of other servers between your backend, like Azure Functions, and your client, like basically a person with a mobile phone who scans this QR code somewhere in the mall. You may have all those different, as I was saying, kind of hops, hubs, and basically endpoints. And that may be really hard to understand at some point what was the original IP address of the user. What you can do in Azure, for example, with Azure Front Door, you can say that I want to know what was that actual address, and the Azure Front Door actually, it will include a special header, and this is like a standard, so it's not like only Azure Front Door can do that. It will include a special header called x_4, and into that header he will basically put all the IP addresses in case there were a lot of different hosts on the route from the client to the backend. It will include all those IP addresses, and you will be able to trace it back to the original IP address of the client. So what I'm doing here, I'm basically checking my headers. I'm trying to get x_4 header, and then because that header can also include, for example, a port number that we were using to make a request, I'm also taking the first header, because that's always, that's always the value of the IP address of my end user. I'm splitting it basically by the column, and then I said I want to have the first part, which is basically the left side, so the IP address only, without the ports. So, and in case everything was successful, I will return this one. In case something failed, I will just return 4 zeros as a basically dummy and not valid IP address in the context of that third party that will try to match it to the exact country. And this is the way basically how I call that third party service and how I actually ask to match the IP address to the country. First of all, I check my environment variables, and the variable called ipstack_key. In that environment variable, I basically store my API key. Then I basically create this simple URL, and again, I create a regular HTTP client, and I'm just executing a GET request for that URL. Here I have the key, so everything is super simple. Then I'm trying to deserialize that response. If everything is okay, I will use it. If not, I will just create an empty object, and I will return that empty object. That will return that final object basically back to my Azure function. And here I will grab it and then, as I was explaining, check the location and do the stuff. So let's see actually how it works. I have those Azure functions up and running on my local host, and here I have a postman, so let's start with the health endpoint. I will go here, I will send this request to my local host, I have healthy, and as you can see, the execution time was only 16 milliseconds. That's also very important because if you have this health endpoint or keep alive endpoint, you also want to make it in a way that it will respond as fast as possible. Now let's check the headers. So I will call this function, and this is basically the response that I have. Let me just switch to the preview. So this is kind of a more fancy way to check it. So this is my headers. Those are my values. What I can do, if needed, I can switch to headers. I can add, for example, a boiko and ms stage. Execute it again. This is Anton boiko. This is ms stage. So as you can see, everything again works as expected here. And now let's check the redirect method. So what I have here, I basically have my URL, but we are also assuming that our Azure function is basically sitting behind the front door. What it means that the front door, as I was saying, will add that X forwarded for header. So let me switch again to my headers. And as you can see, let's say that for this request, we were using 1234. So that was the IP address of our user. Send. We can have a country flag here, which is awesome. Let's check what will happen if we will use this IP address, for example. We will have a different country flag. Let's use another IP address. And we have a different country flag again. So this is the way how we were able basically to hook everything up. So we were using the front door as an entry point. We were using Azure Functions. We were able to get the actual IP address of the client, match it using the database, which was also stored locally with the Azure function itself, match it basically to the exact country, and then based on that country and based on our active business rules, we were able to redirect that user somewhere.